rehabilitation system. I'm grateful to my professor Valdas who supervised this. The main aim of this project is to design post being integrated with maybe a rack post or also the rehabilitation system along with it to construct a whole framework. And the major task is to develop the mechanical and electrical parts of this and also to produce the initial prototype and evaluate the cost of. We'll be discussing multiple aspects, but I have categorized them to overall three major aspects: the overview of the training devices that already exist in the market, and secondly, we'll be designing the real part, like how we design the mechanical and electrical components of this, and finally, we'll be having the cost, how we implemented this, and the overall conclusion of it. In strength training devices, we have majorly two types of training devices. One is based on flywheel technology, which works on kinetic momentum, kinetic force. Let's see this one. So this flywheel technology, and this one is based on motors. The major advantage of this flywheel technology is that it doesn't have any stick points in the full range of motion. And it focuses on the eccentric part of the exercise so that it has major muscular growth as well. And in this particular tonal training device, it helps to measure the athlete's performance and also to provide variable resistance during the exercise performance. Coming to the problem session, what problem we are going to solve? According to the research, people, like elderly people more than 60, are prone to injuries, severe injuries caused by falling down. So this issues can be prevented by using a force plate technology, which helps them to analyze how balanced they are walking or how balanced they are performing a particular exercise. So by this, we can understand that either their body is balanced. If not, we can understand that they are prone to fall, and that could be prevented earlier. And in sports industry, like when athletes are performing, that also could be analyzed and analyze their body balance. Specifically in sports industry, the force plates are used to predict the athlete's injury. Let's say they have one muscle is injured in the right leg, let's say, and the left one, there could be a chance of overstraining one particular muscle. So when they go through a rehabilitation process, this could help them to understand, okay, are they overstraining a particular muscle or not. If so, they could monitor their progress and also check the efficiency of the rehabilitation. And another major property is like they could strategically position the players. Let's say if it is a rugby or football, this helps us to understand each athlete's specific characteristics or ability. So according to that, we could position them in respective places, and this will have a better gain for the player overall. One more point in this is like when a athlete performs a counter movement jump, when two force plates are used, the athlete performs a jump, and when the athlete lands on two legs, we use two force plates, and the speed could be different. When there's a difference in the balance, one would be slightly more and the other would be less. By this, we can understand the difference in the balance. Coming to the design part, second one. So, in order to address this, we are using a material of aluminum 6061 and size of dimension 600 plus 600 into 100. And the safety factor of 40 is obtained. This was obtained and this material was used with the comparison of the materials. This was also majorly chosen because the mass density is comparatively lower compared to other materials. So by which we are focusing on portability. So this will be much easier for them to carry on. So the safety factor was obtained in the SolidWorks deviation divided by the max stress, we get 40. And 200 meters is applied. The reason is like considering a person's weight to be around 100 and the weight lifted by a person to be 100, we took 200 meters. This is the complete integration of the platform along with these track force. Depending upon any type of training devices that we have discussed priorly, that could be attached to the post, and the person would perform the exercise by standing there. And profile of 80 cross 80 was used. This is the electronics of the each single force plate, which is connected to load cells individually so that we have higher precision. And I2C protocol was used for the interaction between the four force plates, and UART communication was used for the visual display of the balance analysis that we will be discussing in the next few slides. So initial prototype was made, and this is we have made only single force plate for prototype because buying with costing pocket money, like it was kind of expensive to buy each and individual load cell. Load cell was one of the most expensive part in the force plates, and the calibration factor was calculated, and it was tested, and this represents each force plate, and when a user is having this plate equal to the right plate, it is considered to be balanced. And when there is deviation, we use the get color function to show the deviation. Let's say when it is maximum like 1000, it is red. When it is like yellow, green, yellow, orange, and red, it goes on that hierarchy. The cost analysis, as said, the load cell is one of the major price increasing factor, and the profile for the integration of the training system, and the overall conclusion corresponding to the tasks. The initial prototype was not that expensive, like 3,132 euros, but let's say we use a real parallel beam load